Hi guys, it's a pleasure to be here again. Thank you for the organizers, thank you for you. This is my second time on ShakaCon, and this time I'm going to present you this XLFLTreaT stuff that I'm working on for a long time. Let's start. Not much changed since last year. We moved to the UK. I'm working for NCC Group now. I just got promoted 2 weeks ago to senior level. I'm still a Hungarian hacker. Thank you very much for that. I'm still a Hungarian hacker, and I have the same certificates like last year. I had half more actually, which is the crash CCT. I passed the theory part, but I had no time to do the practical. I started to do low-level IT stuff when I was 13. I started with Ringo, debuggers and disassemblers, and then I had some major projects like G.I. John, which was a patch for John the Ripper. It made it distributed a long time ago. 2 years ago, I did a research on siege route. I discovered a new technique which you can use to escape siege routed environments, and I created an open source tool that can be downloaded from GitHub. With that tool, you can do lots of techniques to escape siege route, but it's more a proof of concept, and it gives you an idea how to do that. And now, XLFLTreaT or XLFLTreaT. This is my first presentation about this tool, and I'm pleased to be here again. You can find my Twitter username, which is XOR_EIP. You can follow me if you like my presentation, and my LinkedIn profile is there as well. I had several presentations around the globe, in Moscow, Russia, in Austria, Hungary, UK, and actually 2 more in the US, one in Atlanta, in the Hacker Halted, and one here on ShakaCon last year. So the first question for you, because this presentation will be about tunneling mostly. Have you used any tunneling softwares like Cisco, VPN, AnyConnect, sorry? Please raise your hand if you use that. Lots of people, okay. Have you used OpenVPN maybe? Raise your hand again. Okay, so you know what I'm going to talk about. For those who don't know tunnels or VPNs, this is a small figure about this. On the left-hand side, you have your computer, you have your laptop, which is connected to a router modem, which is connected to the internet, right? And you have 2 servers on the right-hand side. One on the top is a tunnel server, a VPN endpoint, and the other one is a server with cat videos. You really want to watch those cat videos, so what you do to connect those servers, download the videos and watch it. How do you do that? You send packets to that server, and the internet works like this. All the routers, the hops between you and the endpoint will know the destination, the original destination of your packets, and the content if it's unencrypted, right? That's how it works. The server will know your original IP address and where to send the data back. If you use tunnels, if you use VPNs, you have to install a VPN endpoint, a server, on your VPN server on the top, on the right-hand side, and then you can make a direct connection with your tunnel. If the solution is encrypted, then all the packets will be encrypted. None of the internal hops, the routers, will know about the content of your packets, and they won't know where your packets are going exactly, because the tunnel will terminate that connection and forward the original packets to the server with cat videos, right? So that way, none of the internal hops will know your original destination, which is the cat server, and the server with cat videos won't know about your original IP, because it will see only the IP of the tunnel. So that's the basics behind the tunneling. So why would you use, or anybody use VPNs or tunnels? the first and best example to access the internal resources and services of your company. For example, if you want to work from home and you need to get access your file server or Outlook, what you do is use VPN, connect to your corporate VPN, get an internal IP address of the company, and that way it's like the same as you are working from the office. Another example for this, if you want to hide your IP address because you are doing BitTorrenting or you are whistleblowers, and I know you guys, you have at least one each and every year, or if you are a journalist and you want to do communication anonymously, then you do VPN. That's one way why would you use VPNs, right? I personally used VPN because my ISP was filtering stuff. I couldn't access NetBIOS ports or secure IMAP secure SMTPS, so I just connected to my VPN, and through that VPN I accessed my own server, so I could send secure mails and receive mails as well. But with tunnels, you can bypass corporate proxy policies or captive portals, and this is tool really about. Do you have any more scenarios when you would use VPNs or tunnels? Raise your hand. Okay. Probably I listed everything on the slide. A few more questions for you guys. Have you done any tunneling? Have you used any softwares that used TCP for tunneling? Raise your hands if you know any. There? Give me one example, please. No. Okay. Let me give you two. Cisco AnyConnect and OpenVPN. What about UDP? I give you a hint. It's on the slide right now. Okay, it's OpenVPN. If you want to use ICMP for tunneling, you can use different solutions like HANS, Ping Tunnel, ICMP TX, and there are lots more which are not on the slide. For DNS, you can use Iodine, which is really famous and used by lots of penetration testers, DNSCAT, and so on. What about HTTP Connect? You can use Proxyfire, but I haven't really found anything else that you can use to tunnel your data through. If you want to use pure HTTP, that's even harder. If you have a proxy that enforces TLS version 1.2, for example, it doesn't allow you to use anything else. There is no tool for that. At least I don't know anything about it. And if you want to use that with Kerberos authentication, you are screwed. You can't really do anything. So you have to create your own tool and do tunneling over that. And that's not really handy. So first, this was my problem. Then I went to Africa from Europe. Actually, I went to Morocco from Italy. It took me 2 days on a ferry. I was in a really small cabin. I was bored. There was Wi-Fi. And I realized that I had to pay really serious money for the internet. For 2 days, you really don't want to do that, but you don't want to be bored, right? Because it's on a ferry. You are on a ferry. It's not a cruise. So it's not like that. And I poked around. I realized that the port 443, which is HTTPS, was unfiltered, but I haven't set up any OpenVPN on that port, so I couldn't do tunneling. So I was screwed again. Next time, I went to Japan from Hungary, which is about 10-hour flight. And on the carrier, we had Wi-Fi. You had to pay, again, serious money to get unfiltered internet access. But I realized after, I poked around a bit, I realized that ICMP was unfiltered. So I could have done ICMP tunneling, but I haven't set up any solution on my server for that, so I couldn't do anything. I was bored again. And this is coming back to me all the time. I set up a DNS tunnel on my server. I'm happy because I don't have to register myself on the airport. I don't have to pay for the internet again. But my solution always crashes, so it's not working, or I just forget to set it up. So with these problems, I started to realize that I have to create something, because for each protocol you have different solutions. You have to configure that tool on your server. You have to find out why it's not working. There is no documentation, or sometimes there is, but you have to read that through. The configuration is different. Most of the tools are end of life or unsupported for a long time, and there is no automation at all. So that's really bad. It's really hard, and it doesn't have to be hard because all the tunneling are the same. So this is when I realized that I have to do something, and I started to write my own tunneling stuff, which is called XLFLTreaT or XLFLTreaT. It depends on how you want to say. And this is how my beast was born. So a bit about tunneling theory. Let me give you a lecture. On the right-hand side, you can see the material scale dolls. What you can do with those dolls, you can put each one into another, and at the end you will have only one. It's the same with tunneling. You can place a tunnel into a tunnel, which can be placed into a tunnel, which can be placed into another tunnel, which makes no sense after a while, but you can still do that. If you do it 1 or 2 times, that's really good for you, and you will see why. So the tunneling really on the left-hand side is that you have a network where almost everything is filtered, but for example, ICMP, the ping, the ping command what you use, it's using ICMP, that's unfiltered. So what you can use, you can encapsulate all the packets that you want to send out into ICMP packets, into ping packets, send it to your server that will decapsulate it, unpack your packets, and send it to the original destination. So you just put the TCP packet into an ICMP, for example, then on the server you unpack your TCP packet from the ICMP, and you are good to go. From the server you can forward your original packets. So my tool, the XLFLTreaT, it's not actually a tool, it's more than that. It's a framework. You can do all the things with this tool. It's Python-based, object-oriented. It handles multi-client for you. It does lots of different things, and I will tell you about that. It's easy because if you want to use it, you only have to go to GitHub. You will only have to go to GitHub because I can't release it today. You clone it, you install the requirements. At the moment, I only have one requirement that you have to install. Then you edit the configuration, which is basically you just replace the IP of your server. You just place it into the configuration, and that's it, nothing else, and you run it. So it's not complicated at all. All the tunnels, the encryption, and the authentication modules, it's modular. So you just copy into the directory, or it will be modular. And you just copy into the directory, and you are done. You just do some configuration in the config file, and that's it. The same with tunnel modules. You just copy the files into the module or support directory, edit the configuration, and you are good to go. It's a framework because you don't have to do anything that is not related strictly to tunneling. So the framework will set up an interface for you. It sets the IP, the routing table. It is multi-client, so it handles all the connections for you. You don't have to care about this. And the authentication and encryption is the same. It's modular. It cares, the framework care about that things. The only thing that you have to do if you want to introduce a new tunnel module, that you have to write your own. So you have to write the protocol that handles the tunneling itself, how you send and receive packets, and maybe the supporting implementation, and that's it. It's really easy. I'm not going to lie to you. It's not 5 minutes. It's maybe 10 or 1 hour, but you can do it in a really short time. I think the best functionality in this framework is the check functionality. I like it the most. It's really easy to use. the theory behind that, if you have a server, from the client side, you just use the check functionality. It sends a challenge to the server, and if the client gets back the results of the challenge, then you will know two things. First, you have an XLFLTreaT server on the other side, and then you have a working tunneling channel. So you can tunnel on that channel. You don't have to do any low-level stuff. You don't have to craft ICMP packets or do an nmap scan. You just set up your server, your client, do the configuration in the config file. You just run the check functionality, which I'm going to show you, and you will know that which module, which protocol is working on that network, which is all load and which are not all load. The other really cool stuff about this, it uses only one interface. So back in time when you used different solutions, for example, Iodine and ICMP-TX and OpenVPN, each solution set up a different interface on your Linux or Windows box, right? So you had to make your own routing, IP table rules, and that kind of things. If you screwed up something, you had to do everything again. It was hard. With this, you have only one interface with all the modules. They are using the same interface. You only have to set up one IP table rule, and that's it. You are good to go. So what happens here? This is the server side. The purple boxes are the modules, different TCP module for every client, one UDP and ICMP for each client. And the yellow lines are the connection with the client. It comes from the internet, of course. When the client sends data in the server, it arrives to the purple box, to the TCP, for example. It sends it to the tunnel interface, which does the decapsulation. It unpacks your packet. It sends to the kernel. The kernel will handle it. It forwards it to the right way, to the original destination for example, for the cat server, the cat video server. And when the video is coming back, it arrives to the kernel. It sees that the original connection, it should be forwarded to the client on the TCP. So it sends to the tunnel interface. It encapsulates that packet. But before that, the packet selector module will decide which module should be addressed with that packet. And it goes back on the green line, and then back to the yellow. So that's the theory behind. It's not only easy to use, but it's easy to develop as well. This is the module tree. Because it's object-oriented, it's pretty easy to create a new module. All the children inherit all the properties and methods from the parent, of course. We have 3 different skeleton modules here: the generic, the stateful, and stateless. These are the basics. These are the skeletons of all modules. They are sharing the same properties and methods that will be used in all modules. So you don't have to modify these. They are just good as they are. At the moment, I have TCP, UDP, ICMP, SOCKS, and HTTP Connect ready. I'm still working on a DNS. I couldn't finish it. I'm sorry about that. I couldn't finish that. But those are working perfectly. If you check the code of the TCP module, that's about 450 lines. And because the HTTP Connect inherits everything, I had to do additional implementation, because that module is using a HTTP proxy with the connect method. I had to implement that part. It only 150 lines. So in 150 lines, I created a new module, which is the HTTP Connect, and with that, based on the TCP, with that you can tunnel everything through an HTTP proxy, which is kind of cool, because all the other solution is like a few thousand lines, because they implement everything else, not just the core tunneling. Let me give you a few examples how easy it is to develop for this framework, or how easy it is to use. For example, if you have a network where only web traffic is allowed on port 80, you just set up the tool on port 80 and you are good to go. You can use it. If the ICMP type 8 packet is disabled, is filtered, then what you do, you just copy the ICMP module, and you just modify the type 8 to something else that you like. If you have an HTTPS proxy on your network which is enforcing TLS version 1.2, it only allows you to connect to sites which are using TLS version 1.2. Then you just copy the TLS or SSL module and you just configure it. You just make sure that it's using TLS version 1.2. That's really easy to do. If you need some kind of special header in the HTTP request, you just copy the HTTP module and set that header. It's one more line and you are done. You don't have to really modify any code. It's really easy to do. And if you want to do out-of-band tunneling, for example, if you want to tunnel all your packets over text or SMS, you just get two phones, connect to your server and client, to your laptop. You implement how you want to send the text, I mean the actual message sending. You implement that and you are good to go. So you can route all your packets over text or SMS. If you have two phones and you implement these, you don't have to care about anything else. If there is some kind of special authentication, for example, Kerberos, you implement Kerberos authentication, which is kind of hard, but you can do that. You implement that, you enable in the configuration, and you are good to go. I'm going to create a white paper about this tool and tunneling itself, and a wiki for the tool, of course, for the framework. But I can't really write everything down. I will try to. So my best hint for you, if you want to use the tool, that read the source as well sometimes if you are stuck. That's the best tip always. So this is the time for the demo. Let me give you a few seconds, please. Can you see it well? Can you read it? No, you can't. Is it better now? Okay. So I SSH'd in to my server, which is an Amazon instance. And I'm going to run the tool, which is pretty easy. You only have to specify, actually you don't even have to specify the server on the server, but I did. So you just run it. It's running HTTP Connect, ICMP, SOX proxy, TCP and UDP on the server. And I go back to the Kali. Can you see this? Is it better to read? Okay. And on the client, you have the configuration, which starts just here. The only thing really that you have to put in the configuration, you have to change in the configuration, is the IP of the server. Then there are some configuration for the server side. It's not important right now. For the client side, MTU, and then you have the modules. We have this TCP generic enabled, UDP generic enabled, ICMP, SOX, and HTTP connect. As you can see, the proxy IP is set to 1111, which is not going to work. It's just for the demo. So what you do, this is the check functionality. You just type ---- check, and it will try to send the challenges, the packets to the server. And if it's red, it's not going to work, obviously, because you can see it here. The SOX proxy is not set to a real IP, I mean, a valid proxy, so it's not going to work. So that's red, checking failed. But the ICMP, the TCP generic, and the UDP is working perfectly. So you go back to the configuration and turn off what you don't want to use. It's pretty easy to do. You just go to enable and modify it from yes to, change it from yes to no. So we are not using TCP, UDP, and the proxy stuff. The only thing that we are using is the ICMP here. So we are doing ICMP tunneling. You don't have to install any new tools for this. You just modify the configuration and that's it. We do a new check again. It works, it still works. So let me start Wireshark. There is nothing now. And let's open the ShakaCon web page. Oh, sorry. My bad. I haven't started. Let me do it again. So instead of check, use the client. It worked. As you can see, there was a lots of TCP because I opened the ShakaCon web page without the tunnel. Then we have ICMP. It's still there. And I open, oh, one more thing. They're both. Okay. So now, if I open the ShakaCon web page, it's going to be a bit slower, but in the background you can see ICMP ping is sent, it's received, reply and request, and in the background it loaded. It's still loading actually. And with the variables you can see the packets are sent and read. So that's basically it. I tried it yesterday before nobody used the Wi-Fi, and it was 800 kilobytes when I stopped the speed, 800 kilobytes per second when I stopped the downloading. Now it's 150, 60. That's all over ICMP, as you can see. So it's pretty nice. It's scaling up. This is how the packets are sent and received. I'm going to stop this, and I'm going to do TCP tunneling. So what I do, I just change the ICMP to no, enable the TCP generic. I do a check again, just to make sure it works. It works because that's green, which is good. And use the client again. Then I can download stuff. It's a bit faster, of course, because it's not ICMP. And as you can see, only TCP is transmitted. I can upload. I can open this web page. This is my employer, and this is how you do tunneling with this tool. It's really easy and it's really handy. Let me stop this and go back to the. Yeah, this is the output of the server. It's pretty clean. Let's stop the server and go back to the presentation. So that was the demo. Thank you. First, I want to give you some hints regarding the offense and defense. I start with the offense because that's my favorite part. With this tool, you can bypass basic and not that basic obstacles if you realize that there is some kind of protocol unfiltered on your network and all the others are filtered, and you can just use this and bypass that kind of filtering, captive portals, for example. Or if you need some kind of special authentication or header, you just modify the source code and that's it. It's pretty easy to do. You can exfiltrate information from networks, which is kind of bad to do, but it helps on the defense as well. And you can get unfiltered internet access with this tool. This is why I started to write. For companies, maybe you are more interested in this. I have some hints. If you are responsible for IT security in your company, you should download this tool, use the check functionality after you configured it properly to figure out whether you can make tunneling in your network. If you can, that's not really a good sign for you because you can probably exfiltrate data with the tool. So my best advice, and I'm telling you, you should do this, try to exfiltrate data. Try to exfiltrate data and try to be the first one in your company, because if you are not the first one in your company, I'm really sorry for you. You know, data breach is not going to help you. So the best thing what you can do is try to exfiltrate data, find out whether you can do that or not. If your SOC is able to detect this kind of communication, you should give them a really good and fat payslip next month, or a good bonus because they are doing really well. And if you have a guest network, for example, for Wi-Fi, or you have a captive portal, then you should do two things. First of all, you should filter all the packets that are externally addressed. So you shouldn't, the user shouldn't be able to connect to any sites or to use any kind of protocols with external IPs. You should filter everything. The only thing that you should do, you should let the guests or the customers on your network only access your captive portal, and after they authenticated themselves, they should be able to access the unfiltered internet. You shouldn't let any other protocols working for them. All DNS queries should be modified. They should point to your captive portals first, and after they authenticated themselves, they should get the original DNS responses. So that way you can prevent DNS tunneling on your network. Unfortunately, I can't give you 100% secure solutions, not today, and probably not tomorrow. What you can do, these are my best advices for you. What you can do is that enforce your HTTP proxy in your company. You don't need any computers to connect to the internet unfiltered directly. You should use HTTP proxy on all servers, on all guest and corporate computers, laptops. That way you can do lots of things. Probably there are exceptions everywhere. You can, of course, do exceptions, but most of the servers and clients should use HTTP proxy. On the HTTP proxy, you can set up whitelisting on ports. You should whitelist port 80 and 443. Probably you won't need any other ports because that's an HTTP proxy and you don't really need anything else than HTTP. You can blacklist websites, for example, porn sites and 9gag Facebook if you don't want your customers or employees browse that in their work time. But it's not going to help on exfiltration or XFilTreaT because that's not very, you can't blacklist everything, right? That's not going to work. With the DNS, what you can do on a corporate network, you should forget about external DNS. Internal DNS should work, so you should be able to resolve all the hosts internally, but none externally. That should be done by the HTTP proxy. You can do that easily. A few more things. If you have an inventory, that's really good for you. You should keep that and keep that updated. If you don't have that, you should start that tomorrow, I guess. That inventory should have the IP, the owner of the IP, the location of the box, and the purpose of the box. So that way, if there is something suspicious going on, you know who to call right away. So that's really important in IT security. And when you have the inventory, then you can start to do baselining, for example, with NetFlow and Bro. With this, you can identify the top talkers. You just create actually a statistical map of your network. You do that every day. You identify the connection between IPs, the frequency of the communication, what protocols are they using, and the volume of the traffic. If you have this statistical map, then you can put it in alert mode, and if there is an unusual traffic, unusual activity on your network, it will alert you, and you will know there is something going on. And you can decide whether it's a data breach, exfiltration, or something that you forgot about. I still have to do some things with the tool. I want to do multi-US, multi-operating support for it, multi-Python version support, of course. I want to create more modules, and so on. It's not commented very well. I want to introduce DNS module before I release it. So unfortunately, I can't release it today. I wanted to share it with you guys, but I can't do that. But you can open that web page, which is XLFLTreaT info, and you can check whether it's released or not. Yeah, I have to do some more things before I release it. So mahalo, everybody. Thank you very much for your attention. I think we have some more time left. So if you have questions, now is the time. Or you can find me on the hallway, or probably in the back room where I play CTF with the others. So any questions today? No questions. Okay, thank you very much. Thank you.